Siddharth Vickram. I am 9 years old and in 4th grade. Today, I will be talking about a type of nanobot that can help the world medically. So what are nanobots? Nanobots are robots around the size of a DNA strand or a cell. Nanobots are made from materials such as silver, DNA sheets, proteins, gold, and more. Nanobots are so small that they can be used inside a human, like me, or an animal body, like my brother. Nanobots in real life. Nanobots in real life. These are either in research or in real time right now. So nanobots in real life have been known, are being used to drill through bacteria, killing it before it can start infecting you. Also, nanobots in real life are being used to test new drugs to make sure they're safe to use. Nanobots are in study of being used to deliver drugs to cells that they can use to kill infectious cells and block blood supply to tumor. So here's the current technology. The bacteria drilling nanobot. This nanobot has the motor part of the nanobot. It consists of molecules that when a blue light shines upon them, they can spin at about 3 million rotations. I'll give you a second to take that in. You might have thought I said something else. So 3 million rotations. And that motion will push it past blood. The blue light activates these bots, as I said. The bot has peptides that recognize enemy cells and binds to them. The spinning rotor, which is the motor part, drills and destroys the enemy cells. And bacteria cannot grow any resistance to these cells since it's an external force using technology. And here's a brief photo that I got when I actually emailed the professors that made them for more information. And I think Julie would probably remember the last time I did this presentation. I think I'm correct.
Yep.
So here's my idea for my nanobot, or people could use these. So this nanobot is activated by sound, since I don't think light could reach all the way that into the body. And I think sound can, because number one, sound can pass through walls, can't it? And while I was in my research, I figured out that there are micro-zinc wires that produce small sparks of electricity to power machines. So maybe we could convert that to a nanozinc wires. The nanozinc wires that could be used to power this nanobot. So where's this on? And the start part of this is that when it gets into the body, it'll search for white blood cells. The certain type of white blood cell it'll look for is a neutrophil. The neutrophil is a white blood cell that goes against pathogens, which this bot is going to go against. So it'll attach to it with its arm to have peptides that can connect to the receptors of the white blood cells. And then after it's going in the body, it will sense a foreign pathogen, and it will unclamp from the white blood cell, and then it will try to go towards the enemy pathogen, and it will shred it. And the pieces the bot doesn't clean, because it's not like a cleaning bot. Maybe I should make another bot to do that work attached to this bot, but that's an idea for later. So that's the end of my presentation. Check out my scratch game, the Nano Circuit 2.0. I'll give you a second to take a picture of this. So, or scan the QR code. I think that's enough time.
Sid, are you going to share your big surprise then in a little more detail?
Yes, and well, that is the end of my presentation. And now I will share the big surprise. So, on a podcast from the podcast that Julie and Jake did. Julie asked me a question on 2 a famous astrophysicist named Neil deGrasse Tyson. Then Jake said that I should send a letter to them and ask if I should have lunch with them. And that's what I did. And so after I wrote the letter, Neil deGrasse Tyson, the astrophysicist, his email viewer actually replied back and gave me tickets to one of his talk shows. And that was like amazing and mind-blowing at the same time. So I want to give a brief but not brief explanation on everything he talked about. Ready?
Yes.
Okay. So first he talked about exoplanets, like planets that are out of the solar system that they track. And okay, yes, you opened the Sky Project. Good job. And these are outside of the solar system, and they track exoplanets that are in front of stars that have solar systems by using this method. So they aim the telescope at it for a few, for a long time. If there's a small dip in light, so they say this is a star and this is a planet. The planet, I know, it's like a half of my head is a star. Yeah, that would be more. So as the planet is passing it, a bit of my head gets cut off. In that sense, a bit of the light from the star would be cut off. Even that small percentage would make a difference in the telescope thanks to advanced technology. And then they would know there's a solar system. And do you want to know what one of the exoplanets is shaped like? I'll give you a hint. It is connected with football. A football. So, because of the tidal forces, instead of shaping it like a sphere, it actually happens to shape it like a football. That's like, wow. And you want to know that from Mars, there is actually a piece of rock in Earth from Mars, and no astronaut ever picked it up in a sense. But do you want to know how? So if you have a bunch of Cheetos, you put them on the bed, then you just grab a rock or like something heavy and then put it on the bed, like slam it onto the bed, like with a force that would apply to be like, the exact force of an asteroid impacting another planet. The rocks the Cheetos just go flying into the air. And that's one thing that actually happened from Mars. Well, that is a possible way that a space rock could come here from Mars. And do you want to know how they figured out that that rock actually originated from Mars? Okay, I want to give you a few moments to guess. Okay, so the gases inside and the minerals in it match the exact same minerals and gases in Mars' atmosphere and in the ground. So that's how they figured out it came from Mars. So isn't that cool how something could travel that far? And there's a worm-shaped object in the picture, which might have been a form of life. So next he talked about water on planets like in our solar system. So one of them is Europa. Europa is one of Jupiter's moons, and that moon actually has water on it. It has water completely on it, but it's all frozen up. There is going to be a mission, probably, I think, that is going to get a bot to drill into Europa and see if there's an underwater ocean under all of that ice. And if there
2032.
What?
In 2032, the ESA is a mission launch for Europa. It'll arrive.
Yes, and then they'll figure out if there's actually an ocean of water under there. If there is, that means there's possibly forms of life under there. Next, there's Ganymede, one of Saturn's moons. And this is really cool because remember the tidal back down there. And that's like, and
Sid, this is a lot. We have to go on to our next presenter. I'm so sorry.
I have two more parts, and well, I'll just skip it and just tell you the end where I had a Q&A session with him. So you're asked to ask one question to him, and I asked a hypothesis I had about if when the universe takes up its whole volume, if that is possible, will gravity take it back into singularity, and will Big Bang happen again? And that repeats all over. He said, according to the calendars, no, not according to the calendars, according to the data, no. So what is going to happen is that the universe is going to expand so rapidly that the space-time cannot take it, and it just rips into fabric. That is the big rip. So keep that on your calendars.
Okay. Well, Sid, thank you.